In this video we're going to use the squeeze theorem to find the limit of this function. So when it comes to multivariable calculus, it's much easier to show that the limit does not exist than it is to show that the limit exists. So for example, if you consider along y equals 0, if the limit heads towards, let's say, 10, and then along the path of x equals 0 it heads towards -7, then you can immediately conclude that the limit does not exist. But to show that the limit exists, you need to show that it heads towards the same place no matter how you approach the origin. You could approach it in a straight line, or you could approach it in a quadratic manner, or you could approach it in a spiral manner, or you could approach it like this. As long as you head towards the origin, you need to show that no matter how you approach the origin, it will always head towards the same place. So to show that a limit exists is much more difficult. So for example, hang on. So with this surface, we've seen that if you approach the origin, remember the origin's here. If you approach it in a straight line, let's say it heads towards, I don't know, let's say 3, and then if you approach it in a quadratic manner, then it heads towards, I don't know, let's say 7. Or if you approach it from this direction, it heads towards negative, let's say 4. All these are different, so you can conclude that the limit does not exist. Consider this surface. Here we suspect the limit is 10. So at the origin, as you approach it, if the limits truly exist, then this thing, take away your suspected limit, which in our case we suspect it's 10. We suspect it's 10. So if the limit truly exists, then this take away 10 should, well, if you take the absolute value, then it should be 0. So we're going to use the same technique to work out the limit of this. So we need to find our suspected limit. So let's consider an easy case where x, let's look at the plane x equals 0. So this is your domain, this is x, this is y. So consider along the plane x equals 0. So consider this plane here. Along this plane, this thing here reduces to this. Along this plane, the limit would be 0. Along the y equals 0 plane, which is this plane here, the limit of this thing here we suspect is 0. So looking at along x equals 0 and y equals 0, we suspect the limit should be 0. If we suspect the limit should be 0. So looking at this, if the limit truly exists, then this thing, take away your suspected limit, should equal 0 when you take the absolute value. So looking at this thing here, take away our suspected limit, we suspect it's 0. We are going to, it should be 0, so we are going to trap this in between two things. This is us using the squeeze theorem. Our aim is to trap this thing in between two things. So let's start again here. So this thing, if the limit truly exists, then this thing, take away our suspected limit, should be 0. So now we are currently here. Well, if you're trying to take the absolute value of one thing, take away another thing, or take away 0, then this whole thing here is the same as this thing here, because all you're doing is take away 0. So you trying to take the limit of this whole thing here is the same as you looking at this. So now, hang on. So now this thing here will always be positive because you're squaring. This thing will always be positive. This thing will always be positive. So so we can rewrite this whole thing here as this, because this thing is always positive. The number 3 is a positive number. This is always positive. This is always positive. Then this whole thing here is exactly the same as this. Just you taking the absolute of something that could be negative. This is positive, always positive, always positive. This is precisely positive. So this is the same as this. And then we can rewrite this as, well, I'm just going to take this block out here. So now you've got one block multiplying with another block. Well, this block here will always be equal to 1 or slightly less than 1 because hang on, because let's imagine y squared is 10. So 10, and then you've got your y squared here, 10. If I add a positive amount, let's say I add 2 is a positive number, then this thing here, 10 over 12 is slightly less than 1. I'm gonna add a different positive amount. Let's say I'm gonna add 1. This is a positive amount. Well, 10 over 11 is slightly less than 0, slightly less than 1. So so I can say that this thing here is always going to be slightly less or equal to well, I can jump from here to here, okay, because I know that well, looking at this is going to be like this. It's going to be less than 1, and then you've got your block here, 3 absolute value of x, because this thing here is going to be slightly less or equal to the 1 here. So I can rewrite this whole thing here as being less than or equal to this thing here. Okay, so remember, our aim is to trap this in between two things. So we are currently at this stage here, and then looking at this, hang on, and then looking at this thing here. This is always positive, this is always positive, this is always positive. The number 3 is a positive number, and then absolute value of x is always positive. So we can definitely be sure that this block here will always be greater or equal to 0. So now we've trapped this thing in between two things. So now take the limit of everything as x and y heads towards the origin. So so take the limit of this, take the limit of this, take the limit of this. That will then take us to here. So as x and y heads towards 0, this thing here this whole thing here will be 0. We don't know what this is doing. This thing here, as x and y heads towards 0, there is no y here, so we can ignore y. As x heads towards 0, then this thing here will head towards 0. So we don't know what this is doing, but we do know that it's trapped in between 0 and 0. In which case we know for sure that this thing here will head towards 0. So we know that the limit here equals 0. Okay. So what that means is if you look at your domain, no matter how you approach the origin, you could approach it like this. Approach the origin like this, and then it will still head towards 0. You could approach it in straight lines. It will approach 0. If you approach it in a quadratic manner, it will still head towards 0. So we know definitely for sure that this thing here, the limit equals 0. No matter how you approach the origin, it will definitely head towards 0. Okay.